This is SpaceTime, Series 29, Episode 65, for broadcast on the 1st of June 2026. Coming up on SpaceTime, NASA confirms its moon-based plans and signs its first contracts. A surprising core reversal deep inside the Earth. And astronomers spot red dwarf stars eating their own planets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has confirmed its plans to have humans living on the moon by 2032. The agency's now released its latest draft for its Lunar South Pole Base project, signing its first contracts as it prepares preliminary work towards the start of construction. The basic plan is similar to that proposed earlier this year. The announcement at NASA headquarters in Washington, D.C. included confirmation of the first contracts for lunar rovers as well as unmanned cargo landers to transport supplies to the lunar surface. NASA Administrator Jared Isaacman announced the first 3 moon-based missions will launch before the end of the year.
On December 18th, President Trump signed a national space policy that reaffirmed America's commitment to leadership in space, to return to the moon, establish an enduring presence, to build the moon base, to invest in the next giant leap capabilities, to ignite an orbital economy, maybe even the foundations of a lunar economy, and launch extraordinary missions of science and discovery. On March 23rd, we shared with the world exactly how we intend to achieve the vision called for in the American Space Superiority Executive Order. Then on April 1st, we took an incredible step in the right direction when the clock hit 0 and Artemis II got underway on an epic test mission of science, discovery, and integrity, bringing the amazing crew home safely to Earth just 10 days later. We are working alongside our lunar lander providers, preparing for Artemis III crew announcement and getting ready to begin stacking Artemis III this summer with a target launch in mid-2027. We are leveraging the NASA playbook from the 1960s, figuring out what works and what doesn't in this epic science of survival, because the moon base is as beautiful as it is hostile. In sunlight, the surface can heat to over 250 degrees. In darkness, it can drop well below minus 200. In the permanently shaded craters, areas of great interest that have been untouched by sunlight for millions, even billions of years, temperatures can fall well below minus 400 degrees. There is no atmosphere to moderate these extremes, no protection from radiation and solar particle events, and the surface is exposed to meteorite impacts, including the kind of light flashes the Artemis II crew observed from orbit. Recognizing this reality, I'm often asked why we send our astronauts into such harsh and dangerous and unforgiving environment of space or the lunar surface, and at such great cost. And we go for the technology we will pioneer to get there, the science and all that we will learn that will make life better here on Earth, to advance humankind on this great adventure, to inspire the next generation to do it better than we can, and to be very clear, to master the skills for where we will inevitably go next. So we are discussing 3 moon-based missions and a series of additional awards with more missions to be announced in the months ahead. Now, Moonbase 1 will be the first privately funded lunar lander mission in history. The Blue Origin Mark I Endurance lander will deliver multiple payloads to the Shackleton Connecting Ridge, a strategic area of the lunar South Pole. In addition to flying 2 NASA science payloads, SCALPs, a lunar retroreflector array, the mission objective is to demonstrate critical capabilities that reduce risk for the human landing system missions. On that note, every mission in support of the lunar base helps us learn and de-risk crewed missions, but this one is especially important because of the role Blue Origin plays in the Artemis program. The target no earlier than launch date is the fall of 2026. Moonbase 2 will be the largest commercial payload delivered to the lunar surface ever, though in this Moonbase endeavor, we certainly hope to be breaking records on nearly every mission. The Astrobotic Griffin lander will carry more than 500 kilograms of cargo, including Astrolab's Flip rover, to the lunar surface. This mission will help mature the capabilities necessary to support future lunar terrain vehicles, autonomous operations, logistics, and especially the LTV astronaut mobility. Moonbase 3 will expand our scientific understanding of the lunar surface. This mission will deliver the first payload selected through NASA's PRISM initiative, a program that brings together universities, researchers, and industry through open competition to solve scientific questions. The anchor scientific mission is Lunar Vertex, which will study lunar swirls, one of the moon's most intriguing mysteries. Now, these unusual formations appear brighter than their surroundings, as portions of the lunar surface are somehow shielded from the effects of the solar wind. Understanding why they exist could improve our understanding of how the lunar environment evolves, how surface materials change over time, and how future infrastructure may perform in these extreme conditions. The Moonbase 3 landings will also deliver payloads from ESA and the Korean Space Agency, demonstrating that the future of lunar exploration is an international effort. Moonbase 2 and 3 are targeted to launch before the end of 2026. Now, these represent the first of more than a dozen missions we expect to announce through the balance of this year as we return, build the base, and never give up the moon again.
NASA Associate Administrator Laurie Glaze says the pathway to a permanent human presence on the moon is being paved by the Artemis missions. In November 2022, Artemis 1 tested the giant SLS Space Launch System vehicle and the Orion spacecraft on an actual flight to the moon and back. Then in April this year, Artemis 2 took the next step, sending a crew of 4 around the moon and back, the first time humans had visited this alien world since the flight of Apollo 17 more than half a century ago.
Artemis 2 is not only a historic journey, it was a comprehensive test of NASA's capabilities as we push farther from Earth. The Space Launch System delivered our crew to orbit with precision. The Orion's life support systems, navigation, communications, camera systems, and heat shield all performed well. Each of these successes validated the technologies and processes we'll rely on as missions become more ambitious and more complex. Where the systems didn't perform as expected, we gained important information to help us improve on future flights. Artemis 2 proved that NASA is ready for the next step. And that next step is coming fast. Artemis 3 will conduct critical integrated tests in Earth orbit, including rendezvous and docking with our commercial landers. Artemis 3 hardware, from the SLS core stage to Orion's modules to lander partner systems, is moving into final integration flight readiness development. And Artemis 4 and 5 hardware is already flowing to the Kennedy Space Center from other centers and partner facilities around the U.S. and the world. We're moving toward the cadence necessary for a sustained deep space program. Steady, accelerated, and continuously learning as we prepare to return to the lunar surface. And that then brings us to the future. Moonbase. Moonbase will be home base for our Artemis crews and will encompass long-duration stays, expanded robotic and human capabilities, and an enduring presence on the lunar surface. Everything we tested and learned on Artemis 2, the systems, the teamwork, the operational tempo, feeds directly into our ability to build a sustainable foothold on the moon. With Moonbase, Artemis astronauts will stay longer, explore farther, and conduct the kinds of science that advances exploration itself, understanding how humans operate off-world, how we build infrastructure, and how we prepare for Mars.
Meanwhile, NASA Moonbase executive Carlos Garcia Galan has announced the first contracts for the Moonbase project, with Blue Origin to provide the lunar landers and both Astrolab and Lunar Outpost to build the first of the rovers.
From now through 29, we're going to work to make sure that getting to the lunar surface is a high reliability endeavor. Many assets we can deliver there. We're also going to test and experiments the science of survival. We're going to experiment on the things that we know are ahead of us that we're going to need to build a permanent infrastructure, which is happening on phase 2, and then permanent habitation on phase 3. To do this, we're building and working on many different systems, from transportation to mobility, and we've broadcasted a pretty high cadence of missions that will help us to get there. Phase 1, for example, will have 25 launches, 21 landings, and we're planning to deliver about 4 metric tons of cargo to the surface of the moon. And we want to graduate from that to 60 metric tons to 150 by the time we get to phase 3. We envision multiple assets, those 21 landings, is to deploy many types of assets in different areas where we have objectives for science, or we think it's a good place to develop the moon base. We're going to have landers, small and medium class. We're going to have constellations of satellites that will enable communication, navigation, pointing, observation. We're going to have rovers and LTVs, and also we're going to have drones. Blue Origin's lunar lander product line has 2 variants. Mark 1, which is the uncrewed version, is what we're going to be using for the delivery of the LTVs, and Mark 2, which is the crew lander mission. So using Mark 1s will also reduce the risk for future crewed missions there. Mark 1 is the same type of vehicle as Endurance, which is featured in Moonbase 1, the first mission to the lunar surface. Mark 1 type of spacecraft is also going to deliver the Viper rover later in the fall of 2027. As the lunar roving vehicle, vehicle during the Apollo program, the LTV will give astronauts the ability to further conduct scientific research around the moon. But it's going to do a lot more than that, because in this case, we need it to work all year round. We need them to be on the surface doing things that basically prospect the surface, scope around to potential landing sites, or go to areas of deep scientific objectives. So the LTVs are both crewed and autonomous rovers. They're a mix between the Apollo lunar roving vehicle and a Mars-style rover. The LTVs will have a mass of about 1 metric ton, or a little bit less than that, and will have to be in a configuration that is kind of compressed to be able to fit on those landers. They're designed to traverse about 200 kilometers from where they're dropped off, which is 4 times greater than any rover has ever traveled on the moon or Mars. They can be telerobotically operated by people on the ground. They can work autonomously, and of course, when we have human crewed missions, they'll be driven by the humans. These things can go up to 10 kilometers per hour and go up and down slopes of like 20 degrees. The first LTV award winner, Astrolab has adapted its Flex rover architecture to deploy the Crew Lunar Vehicle number 1. This new vehicle is smaller, lighter, and can accommodate up to 2 crew. CLV-1 has a maximum mass of 950 kilograms and can reach speeds up to 10 kilometers per hour. Astrolab is also building the Flip rover, which has a lot of the features that will then be carried over to the Lunar Terrain vehicle. So imagine the first rover, because we're going to have cameras, we're going to have payloads, basically bringing us with them in real life, going to places we have never seen of the moon, testing us and giving us key ground truth data so we can build on that. The second LTV provider, Lunar Outpost, unveiled a new class of rover called Pegasus, which is what we're going to deliver to the surface of the moon. Pegasus is a pared-down version of Lunar Outpost Eagle lunar terrain vehicle. Pegasus is a lighter weight and will be ready to fly on earlier missions as we've asked and demanded. They will do things like autonomous driving, terrain mapping, and identify future potential moon base sites. Pegasus can carry up to 2 crew members and travel 10 kilometers per hour on the lunar surface and, like I said, go through steep slopes and terrains. These awards are incredibly important to the next steps of phase 1, because we have to be able to move around the surface and start looking and gaining the knowledge we need to build up on the moon base. Part of that also is Moonfall. Moonfall is the first lunar drone capability that we're going to have, and it's going to accomplish different objectives. The first is demonstrate the technology. It is going to be the first robotic mobile platform with the range to quickly explore sites interesting at the lunar South Pole. The variances in lighting, thermal gradients are gigantic on the lunar surface. And we basically have a range of like 1 meter dedicated information on the different areas we want to go to. So in that 1 meter, if we're wrong, or if we're off a little bit, those ranges of 400-500 degrees in temperature can be a key aspect that we need to overcome. These drones will allow us to go, cover a broader range of areas that we unprospect and get that ground truth. It can demonstrate the ability to take off and land in multiple locations with precision under South Pole lighting conditions and terrain features. Also, it will utilize available electronics so we can develop them quickly and deploy them where we need. One of the key things that we want to put on these drones is survive the night technology. So not only can they accomplish the mission, they can hop, go to multiple locations, but they can also survive the long lunar nights. So when they get sun again, they can serve a permanent objective wherever they ended up at. It could be observation, it could be communications, or something else. Another key objective is site characterization, so we'll be able to map the surface at centimeter scale resolution, allowing us to beef up our orbital databases and reduce the risk for future landings. It will prospect for water and ice in the subsurface of the moon. It can go look into the surface of the moon about 1 meter in depth across tens of kilometers. It will also characterize the radiation environment before we send other assets or crews to the surface and provide a geodetic framework for navigation using retroreflectors. Whatever we put these drones, it will provide much more of a capability for precision landing for whatever landing is coming into that area. And then we'll have cameras, of course, on all of them and be able to observe around the territory. The next objective is imaging. So high resolution imagery across across all mission phases, including the deployment, the landing, and nominal operations of, staying in situ or hopping around. It will continue image collection during extended mission, and it will analyze the different sites for unprecedented detail, basically allowing us to build our understanding of soil mechanics, the terrain, the lighting conditions in situ of wherever we want to go. It will help us build a digital terrain map of different landing sites on the moon and prospect moon-based sites.
This is SpaceTime. Still to come, a surprising core reversal deep inside the Earth, and red dwarf stars detected eating their own planets. All that and more still to come on SpaceTime. The European Space Agency has discovered a surprising flow reversal of Earth's liquid outer core, apparently changing direction in 2010. The molten core, which swirls around 2,200 kilometres below the Earth's surface, generates our planet's geomagnetic field. By measuring small changes in the magnetic field, scientists have historically inferred the core flows mainly westwards. But then in 2010, it unexpectedly changed direction deep beneath the Pacific Ocean and started moving strongly in an easterly flow. The reasons for this unexpected reversal in the flow of the molten material is still a mystery. The findings, reported in the Journal of Studies of Earth's Deep Interior, are based on a combination of readings using both ground-based observations and satellite data collected between 1997 and 2025. The research found that in 2010, a broad region of iron-rich fluid beneath the equatorial Pacific Ocean suddenly switched direction from flowing mainly weakly towards the west to flowing strongly eastwards. The outer core was previously thought to move in a comparatively stable manner, and so this dramatic change of flow shows that this is not always the case. The findings provide insights into the turbulent processes that generate Earth's magnetic field. The study's lead author, Frederick Dale Madsen from the University of Edinburgh, says the large-scale flow reversal beneath the Pacific raises new questions about the Earth's deep interior. Scientists now want to understand whether the reversal represents a short-lived fluctuation, part of a repeating oscillation, or a new stable equilibrium for core circulation. Continued monitoring will be essential in order to determine how the flow evolves in coming years. The model used in the research suggests that this Pacific eastwards flow has weakened since 2020. Madsen says the rise of the strong eastward flow in the Pacific is contemporary with a change in behaviour in the planet's solid inner core based on geodesy and seismic data. The Earth's magnetic field is a geodynamo generated by motion of the liquid outer core, where electrically conducting molten iron circulates around the solid iron inner core. This geodynamo is constantly evolving, but many of its long-term flow patterns have always appeared to be relatively consistent over decades of observation. This is SpaceTime. Still to come, astronomers have discovered some of the strongest evidence yet that stars eat their own offspring. And later in the Science Report, a new species of giant mosasaur fossil discovered in Texas. All that and more still to come on SpaceTime. Astronomers have discovered some of the strongest evidence yet that stars eat their offspring, consuming their own orbiting planets. The findings, reported in the Journal of the Monthly Notices of the Royal Astronomical Society, supports the long-held belief that young stars are capable of destroying nearby worlds as planetary systems form. Astronomers studied thousands of stars and found evidence that 6 spectral type M red dwarf stars, the smallest, coolest, and most common type of star in the universe, have engulfed Earth-like rocky planets orbiting around them. The study's lead author, Robin Jeffries from Keele University, says the giveaway was the detection of the doomed planet's chemical signatures. Jeffries says some of the red dwarf stars contain lithium, a chemical element that shouldn't be there. Red dwarfs are smaller and cooler than our Sun, with surface temperatures of less than 2,000 degrees, but inside they're still extremely hot, and this heat should be enough to destroy all of their fragile lithium in nuclear reactions shortly after they form. So, finding the presence of lithium in their atmospheres could signal the engulfment of a still lithium-rich material accreted from a surrounding planetary system. Jeffries and colleagues looked at observations of young star clusters collected by the European Space Agency's Gaia European Southern Observatory Spectroscopic Survey, a project which covered thousands of stars. Unlike isolated stars, those found in clusters have well understood ages and masses, and the presence of many similar siblings, which are all born from the same initial material, means that even small chemical abundance differences are easier to establish. And the authors identified 6 different red dwarf stars in 3 separate clusters which had much higher lithium content than the other stars of a similar spectral type. Their analysis suggests that these stars had consumed their surrounding Earth-like planets, well, at least planets of between 3 and 10 Earth masses, enough to provide a fresh burst of lithium to an otherwise lithium-depleted atmosphere. These engulfment events, as they've been called, have long been theorized as a possible, even probable outcome during early planetary system formation, and may even have happened earlier in our own solar system. Now, if this explanation does prove correct, a new window will have opened up into the early lives of planetary systems, allowing the quantity and timing of planetary engulfment to be further investigated. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study claims a cocktail of tomato and soy juice is loaded with compounds which could help lower inflammatory proteins in healthy adults with obesity within just 4 weeks. The findings, reported in the journal Molecular Nutrition and Food Research, shows the tomato soy juice cocktail contained high levels of the plant-based compound lycopene as well as soy isoflavones, both of which are believed to have antioxidant and anti-inflammatory properties. Now, this was a really small study. It involved just 12 healthy adults with obesity who consumed 2 6-ounce cans of tomato soy juice every day for 4 weeks. Then, after a washout period, they consumed a low carotenoid-controlled tomato juice for 4 weeks. The authors took blood samples testing for cytokines. These are pro-inflammatory proteins produced by the immune system, and only the tomato soy juice combo resulted in a significant reduction in 3 key cytokines: interleukin IL-5, interleukin 12p70, and granulocyte macrophage colony stimulating factor, as well as showing a downward trend in tumour necrosis factor alpha. Paleontologists have identified fossils of a new species of giant mosasaur, a marine reptile that roamed the oceans 80 million years ago during the age of the dinosaurs. A report in the Bulletin of the American Museum of Natural History claims the creature, named Tylosaurus rex, or king of the Tylosaurs, was more than 13 metres long. The fossils were unearthed at a dig site in northern Texas. New research suggests that a sodium-ion battery used in some foreign electric vehicles could become a genuine low-cost rival to Tesla's lithium-ion technology. The study's authors independently tested 120 battery cells using a range of physical and chemical techniques in order to compare performance against Tesla's technology under real-world conditions. They found the batteries matched Tesla's in several key areas and performed better than expected, although it did struggle to charge efficiently in cold temperatures. The findings, published in the journal Cell Reports Physical Science, suggest targeted improvements could make sodium-ion batteries a viable alternative for shorter-range vehicles, as well as large-scale energy storage. A United States congressman claims he knows of an immovable giant flying saucer so big, authorities were forced to construct an entire building around it in order to try and hide the vehicle from the public. The skeptic's Tim Mendham says UFO conspiracy theorists claim this hidden flying saucer is located on the outskirts of Seoul in South Korea.
This was raised a few years ago, that these enormous UFOs, they started off being 1, and then they ended up being about 13 of these things. They're so big they can't be moved, so they put a building up around it. And there's a particular one in South Korea, I think it is, that it's round. Naturally, if you're going to hide a UFO, you build a building that looks like a UFO around it. So it's a big round building. And these sort of things are being raised by the the intelligentsia of the world, i.e. an American congressman who was saying that these things exist. A lovely quote saying they're in plain sight in a secret overseas location, which doesn't really make sense. Believed to be on the outskirts of Seoul in South Korea. This is the secret location where they know where it is, and it's in plain sight in a secret place. Logic is never a strong point with these sort of people, and they don't look at it that closely.
Representative Eric Burlinson, and he claims that the president has been fully briefed on the existence of aliens.
Yes, I'm sure he has been. I think he's not saying the one in Korea is the one, but he's saying these things exist and we need to reveal them. And he's actually never seen one, and he doesn't actually have a lot of evidence. He didn't refer to where it is, but he says bureaucratic hurdles are making it difficult to ratify the theory. In other words, he's making a lot of claims, and then if you ask him a few times, he says, well, I don't really know. I don't have the evidence. I've never seen it. I've been told third hand, fourth hand, fifth hand that it exists, and that therefore, but I know it's there. And he doesn't want to mention the country because I heard of it inside of a closed setting and I want to protect my classification level. Oh dear. American congressman. It's one of the things that the Australian journalist Ross Coulthard has been pushing very heavily, and of course he keeps saying that any day now. I can't believe Ross Coulthard
pushing a UFO story. Not such a level-headed person.
Yeah, I know. You won everything. Obviously, I think it says something about the winners of prizes. He's been pushing, or how he's gone down the rabbit hole. Every year, he's saying it's going to happen.
Winners of Walkleys, that's for sure.
Yeah. He says, I never won one, so... But he's pushing these things that any day now, next year is going to be the big revelation. It's all going to be revealed. It's all going to happen. And he's been saying this for years, as every UFO proponent has been saying since the 1940s, that any day now, this year is going to be revealed, the secrets are going to be out, and 70 years later they haven't been. So after a while, you start to think, will they ever be?
That's the skeptic's Tim Mendham. And for the record, the structure in question in South Korea is nothing more than a common vortac used for aircraft navigation. Its 360-degree line of sight is key to providing an omnidirectional distance measuring emitter system. So, I guess mystery solved. But then again, that's what we do. This is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.